In this video, we will be looking at z-scores. By the end of this lesson, you should be able to, given data, calculate and interpret z-scores for a data set. By the end of this lesson, you will also be able to, given a z-score, calculate a data point. So let's take a look at our first situation. This says that the average, if we remember average, is another word for mean. The average Asian elephant weighs 8,800 pounds with a standard deviation of 1,500 pounds. Spike, the Asian elephant, at the Smithsonian National Zoo weighs 13,000 pounds. So we have a situation describing the average Asian elephants and then one specific one named Spike. In our next part of the problem, it says the average, again, that's the mean, truck weighs 6,000 pounds with a standard deviation of 600 pounds. Spike's truck weighs 7,800 pounds. So again, we have average trucks, okay, compared to Spike's specific truck. So the first question we can answer right away, which is heavier, Spike or his truck? So if we look at this, Spike weighs 13,000 pounds and his truck weighs 7,000 pounds. So who is heavier? Spike. Spike is heavier because 13,000 is greater than 7,800. Okay, so he's heavier. The next question says, which is heaviest in its own group? So is the elephant, is Spike himself heavier compared to other elephants, or is the truck heavier compared to other trucks? So this we're going to need to talk about some more information to come back and answer. So let's first look at some definitions, okay? The measures of dispersion, we've talked about some of these already, tell you how the data is spread out. We've already talked about these in our other lessons, the range, the interquartile range, and the standard deviation. All of these give us an idea of how close together or spread out the data is. Specifically, our standard deviation tells us how spread out the data is from the mean. We talked about this in our last lesson, how far away data is from the mean. Today, we're going to introduce and talk about z-scores. This tells us how many standard deviations a single observation is from the mean. A single observation. So looking at one specific thing, just like in our situation number one, we had all the Asian elephants, we had the average, and then we had one specific one, Spike. We had all the average trucks, and we have one specific one, Spike's truck. So that's that specific observation. So it says on your notes, consider the following sample from a population with this symbol, remember, means standard deviation. And this symbol, we have a mean of 30. Okay, so observation, so one of the observations is 31. It has a z-score of 0.5. This means it is 0.5 standard deviations from the mean. Okay, if we look at it here, 29 is negative 0.5 standard deviations from the mean. Okay, so down here we have some more descriptions. A z-score of 0 is the mean. So if we notice here z-score, if we look at here z-score, that means I have a z-score of 0. That means 30 is my mean. So here we can see 30 is my mean, and that's what it says in the problem. A positive z-score is above the mean. So here if I look at my observation of 31, it's 0.5 standard deviations above the mean. That makes sense. 31 is above 30. So is 35. We have a z-score of 2.5. 33.5, we have a z-score of 1.5. So if a positive z-score is above the mean, a negative z-score is going to be below the mean. So again, if you look at 29, that's going to be below 30, and we have a negative z-score. So let's go ahead and mark the mean and the standard deviation and chart the observations. So again, the observations are the specific data points on the number line. So let's go ahead first and mark our mean. Our mean is here at 30. There is my mean. So I know one standard deviation is 2. So if I add 2 to 30, I'm at 32. There's one standard deviation. If I add 2 again, 32 plus 2 is 34. There's 2 standard deviations. And if I add 2 again, here is my 3 standard deviations. And remember, from 2 standard deviations on is considered unusual. Okay, anything above 2 standard deviations is considered unusual. If we go in our other direction, I have 30. I'm going to subtract 2 and be at 28. That's one standard deviation below the mean. If I subtract 2 again, I land here at 26. This is minus 2 standard deviations. Again, I'm going to be unusual if I am less than 2 standard deviations away from here. Everything from negative 2 standard deviations to 2 standard deviations is considered usual. And then we become unusual outside of there. Okay, and let's chart our points. So I have 31, 29, 35, 33.5, 37, 30, and 26, and 28.25. So we can see all of our data points plotted out on our chart there. So next we're going to look at our z-score formula, okay? And we are going to use this formula to compute z-scores as well as find some missing information. So we look at our formula, it says z equals x minus, remember this is our mean symbol, over my standard deviation. Okay, and my x here is an observation. It's one single data value. Again, going back to our elephant Spike, okay, we had our average elephants and one specific one. He's that one observation. And then we have our average trucks and his specific truck. That's the other observation. So let's go ahead and practice this. So these first examples say, on a certain test, the class average, again, average is another word for mean, was 76 points with a standard deviation of 3. So let's calculate Kelly. Kelly's a specific student in the class. Her z-score, if her test score was an 83. And then the second part says, is her score unusual? Let's go ahead and fill in some of this information. So I know now that her mean, or the mean of the test, was 76. I have a standard deviation of 3. And then her specific test score, or this observation, x, is equal to 83. So now I'm going to substitute that into my formula. I am looking for z. I want to know her z-score. So I'm going to substitute in here my x, which is 83, minus my mean, which is 76, all over my standard deviation, which is 3. And if you type that in your calculator, when we type this into our calculator, we can use alpha, y equals, enter, and type in 83 minus 76 over 3. Hit enter. I don't really want a fraction, I want a decimal, so I'm going to hit math, go down to decimal, enter, and there we go, 2.3. Okay, so it's about equal to 2.3. So my second part of my equation says, is her score unusual? Now remember what we said, if we had a z-score, If we were 2 standard deviations or more away from the mean, we were unusual. So this is my z-score here. So 2 or greater is unusual. And here we have greater than 2 z-score. So yes, we are greater than 2 standard deviations from the mean. Okay, my z-score is 2.3. So yes, her score is unusual. Letter B says if Kia had a z-score of 1.5, what was her test score? Now remember back to the last problem, her test score was X. So we don't know what X is here. We don't know the observation, but I do know the z-score. So this time, instead of writing z equals, I'm going to write 1.5 equals. This time, I don't know my z-score. I don't know X, but it's the same mean, and it's the same standard deviation. But now I can't just type this into my calculator. I need to solve for X. Okay, so now I'm going to multiply both sides by 3 to cancel out my 3's. 3 times 1.5 will give me 4.5 is equal to X minus 76. I'm going to add 76 to both sides to solve for X. And I'm going to get X is equal to 4.5 plus 76, going to get me 80.5. So that would be someone's test score. That would be Kia's test score if she had a z-score of 1.5. We've reached the end of our video. Please make sure you bring your notes to class, and we will continue to practice more z-score problems together.